Chapter 3, Decisions, Part 2. So it's very common to put a semicolon at the end of the if statement, as we talked about briefly in the last section. This could be syntactically correct, but logically wrong, meaning you might, in some circumstances, you won't get a syntax error for this, but your code won't work as you expect. In this example shown, it would always subtract 1 from floor, regardless of whether or not floor was greater than 13. The conditional operator is a shortcut that you may find useful. The conditional operator is the only ternary operator in Java, and what that means, ternary, means that that operator requires 3 operands, and those operands are the condition, the true branch, and the false branch. The operator is the question mark and the colon. So the condition in this example is floor greater than 13. If that's true, we follow the true branch and say floor minus 1. If that's false, we follow the false branch and say floor. You'll notice that this conditional operator expression appears on the right-hand side of an equal sign of the assignment operator. And so what that means is, if it's true, floor minus 1 will get stored in actual floor. If it's false, floor will be stored in actual floor. So comparing numbers, there are 6 relational operators in Java: greater than or equal to, less than or equal to, and not equal to. You'll notice this table shows their equivalent in math notation with which you might be more familiar. I encourage you to memorize these Java operators. There's no easier, softer way. Just memorize what they are so that you'll know them when you need to use them. Beware the double equal sign. It's the assignment operator. If you use the single equal sign, the double equal sign is the relational operator testing for equivalence. The single equal sign is the assignment operator. And you want to make sure when you're testing for equivalence that you use 2 equal signs rather than 1. In comparisons, you might have floor greater than 13. So all of these relational operators are binary operators, and what that means is they need 2 operands, one on the left and one on the right. So you can examine these examples here. Note when we're checking for equality that we use 2 equal signs. Now look at the second half of this slide. I want to show comparisons with strings. A string is what's known as a reference type. That means that the variable, in this case string input, the variable input does not store y or n. It stores the address of y or n. So we have to use the string handling methods such as equals to compare strings. So in this case, we're saying if input.equals y, notice that y is in double quotes because we want to compare it with the string y. If those are equal, the equals method will return true. If they are not equal, the equals method will return false. Also notice, or recall, that Java is case sensitive. So uppercase Y is different from lowercase y, and you can instead use equals ignore case, which is another method should you choose to not want it to be case sensitive. Let's look at the last example, comparing floating point numbers. Because of the way that floating point numbers are stored, there may be rounding errors. So testing for equivalence is risky because the numbers might be essentially the same, but just have very slight rounding errors that cause them to be different. So what we do is we compare to the absolute value of the difference between 2 double values. In this case, if math.abs x minus y is less than epsilon. Well, epsilon is a constant that we just created to stand for a very small number. Notice that it's 1e to the minus 14. So that is a 1 with 14 zeros to the left of it and a decimal place. So it's a very small number. We're looking at the absolute value of the difference between x and y. So we subtract y from x, and then we take the absolute value because we don't care positive or negative. We're just looking at the difference between those 2 numbers. And if it's less than this very small number epsilon, then we say, they're equal. And that's how we compare for equivalence for floating point numbers and take into account those rounding errors that might occur. Order precedence. The order precedence when performing Boolean expressions is arithmetic operators come first, then relational operators, and finally logic operators, which we haven't gotten to yet. So if we say if floor greater than height plus 1, we do the height plus 1 first and then compare that result with floor. Here's an example of relational operators. And you can examine you can hit the pause button and examine all of these yourself. As we mentioned previously, comparing strings are special because strings are reference types and not primitive types. So we don't use the double equal sign, the equivalency operator, excuse me. We have to use the equals method from the string class, as in string1 dot equals string2. If those two strings are the same, including case sensitivity, then that method will return a true. A common error is when comparing floating point numbers to use the double equal sign, and as we mentioned previously, round-off errors can lead to unexpected results. So rather than saying if r times r equals 2.0, we look at the absolute value of the difference. Can you remember how we did that? Hit pause and see if you can work it out for yourself. Here is an example showing the solution to that problem on the previous slide. We're looking for those numbers to be close enough, the difference between them being so slight that it really doesn't matter. We create a constant called epsilon that we set to 1e to the negative 14. And then we, in this case, we're setting up a variable r equal to math.square root 2, and then we're saying if math.abs r times r. What is r times r? It's r squared, right? So we're looking at the absolute value of the difference. In that case, r times r is r squared, and we're subtracting 2 because we're looking at the difference. Is r times r different from 2.0? Think about that. If we get the square root of 2 and then we multiply the square root of 2 times the square root of 2, we should get 2 again. And if the absolute value of the difference is very, very small, we say that they are equivalent. It's a common error to use a double equal sign to compare strings, but again, that will compare the address of the string and not the string itself. So it compares the location and not the contents of that variable.